The objective of this experiment is to determine the coefficient of static of different surfaces. Force and velocity are vector quantities that have both magnitude and direction. Velocity is the speed in a specified direction with which a given object is traveling. Force exists when the object accelerates or undergoes a change in its velocity. A body at rest or in equilibrium exhibits resultant force, or the sum of all forces acting on the body is zero. Gravity is an attractive force that exists between two masses. The magnitude of the force depends on the magnitude of the masses. The gravitational force that acts on an object on Earth is approximated as Fg equal to mg, where m is the mass of the object and g is the gravitational acceleration. The magnitude of the gravitational force exerted on an object is referred to as its weight. Normal force is a contact force that acts in the normal direction or perpendicular to the contact surface between two objects. Figure 5.1 shows the free body diagram of a mass m lying on a horizontal surface where the normal force N is equal in magnitude to the gravitational force mg. Friction is the force that resists the relative motion of one surface in contact with another. There are two types of friction, which is static and kinetic. Static friction is the friction that acts on object that is at rest. Static friction is the force that must be overcome in order to move a static object. The maximum value of static friction force is given by static frictional force is equal to coefficient of static multiplied by normal force, where μs is the coefficient of static friction and n the normal force. The coefficient of static friction is a dimensionless constant that depends on the object and the surface it is laying upon. Kinetic friction is the friction that acts on a moving object, and the kinetic frictional force is given by kinetic force is equal to coefficient of kinetic friction multiplied by normal force, where μk is the coefficient of kinetic friction and n is the normal force. In this experiment, the frictional force between a wooden block and the rubber surface on a horizontal and inclined plane will be measured, and from the plot data, the coefficients of static friction will be obtained.
The apparatus for this experiment is 50-gram masses, tabletop, 10 Newton spring scale, and a wooden block with a rubber covered at one side. Next, for the procedure of the experiment, first, the mass of the wooden block recorded as m was measured. Number 2, the apparatus was set up as shown in figure. And number 3, the tabletop was made sure to be stable and horizontal to the ground. Next, number 4, the spring scale and wooden block were attached. Both spring scale and wooden block was placed horizontally on the tabletop. The rubber side of the block was faced down. A mass with 50-gram weight was placed on the wooden block. Number 6, the spring was pulled slowly. The spring scale's reading was recorded once the block started to move. Number 7, step 4 until 5 were repeated for 3 trials. Number 8, another 50-gram mass was added on the wooden block, and step 5 to 6 were repeated until total of mass is 500 gram was on the wooden block. Number 9, step 1 until step 8 were repeated, but this time the rubber side of the block was made sure to face upward. Then the data was tabulated in table 5.1.
So this is the result that we are obtained in experiment. For the mass, we added 100 gram of mass for each experiment. For total mass, we need to add mass wooden block. We need to add mass of wooden block plus mass. So this is the result of rubber surface towards the floor. This is the result of non-rubber surface towards the floor.
First question, how can anti-lock brakes stop a car in a shorter distance than regular brakes? Anti-lock braking system ABS are designed to help prevent the wheels from locking up during braking, thereby allowing the driver to maintain steering control and potentially stop the vehicle in a shorter distance compared to regular brakes. Question number 2. From your experiment, which material has the highest coefficient of static friction? Does this agree with your hypothesis? What do you think determines the coefficient of static friction? Material rubber used to interact with the floor has the highest coefficient of static friction. This statement matches with hypothesis created because rubber is a very sticky substance and contains long chains of link to each other and straighten them. Response object of friction to flow determine the coefficient of static friction. Question number 3. Once the mass begins to slide, does it move smoothly or does it undergo stop and go motion? Explain the motion. The mass will begin by undergoing through stop and go motion. The motion undergoes stop because of traction applied on the floor and it has friction. This will grip the wooden block from moving freely and cause slow pace movement till it stops naturally.
My name is Amira Aisha binti Amirul Zakwan, and I will be explaining the analysis part of this lab report. Okay, so the first question in the analysis part is to draw the free body diagram of this experiment setup. And this step is actually very useful because we get to identify all of the existing force that acts on the body. And as you can see over here, there is actually three forces. So there is normal force, which is perpendicular to where the object is situated, and then we have weight, which is going downwards, and then we have the pulling force since we pulled the wooden block to the right, and then we have the frictional force, which is always opposite to the direction of the object's motion. So the frictional force direction is to the left. Now this step is also useful because when we are plotting the graph later on, we are asked to plot the frictional force against normal force. And as you can see over here, normal force is not given, but we can calculate it by observing the free body diagram. So as you can see over here, the object is not moving in the y component, so the total forces that exist in the y component is equals to 0. But since there is normal force and also weight which lies on the y component, so the normal force plus with negative w, negative weight, since the weight is going downward, so it has the negative value, is equals to 0. Now when you rearrange this, you can actually see that normal force is equal to the weight, so N equals to mg. Now we already calculated this beforehand while tabulating the data and the results. We will look into the graph that I have already plotted, and of course in every graph you need to have the best fit line. So in order to obtain that best fit line, we need to find the centroid. So the centroid is actually kind of like the center coordinate for the graph. So to actually find the centroid, we need to calculate the sum of the data on the horizontal, on the x-axis, and then divide that by the number of data that we have, and then we have to repeat the same thing to find the coordinate on the y-axis. So the data on the sum of the data on the y-axis divide by the number of data on the y-axis. So as you can see over here, I have already calculated it, and in the end I got the centroid for the first graph, which is graph of frictional force against normal force for the rubber surface. The centroid is 3.75 comma 3.26. So that is the coordinate. And I have plotted it over here. As you can see, there is this tiny dot, as you can see, like a really a bit darkened point compared to the other point that I have plotted. So that is the centroid. And now we can find the coefficient of the static frictional force. Now you may wonder, what does it have to do with the graph? Why do we have to plot the graph in order to find the coefficient of the static frictional force? This is because the static frictional force, the coefficient of the static frictional force, is actually in the gradient of the graph. Now I'm going to show you guys how it actually relates to each other. So as you can see, this is a straight line graph, right? It's a straight line equation. It's a straight line graph, and we know that the general equation for a straight line graph is y equals to mx plus c. Now that is the general equation. But from our graph, since we plotted the frictional force against normal force, we can actually write it down like this. So frictional force equals to the formula to find the frictional force is Fs equals to the coefficient of the static frictional force times with the normal force. Now, if you compare this equation with the general equation of a straight line graph, we can see that the y-axis is actually the frictional force. Now, this is true, as we can see on our graph. The y-axis is the frictional force. And then the x-axis, as you can see here, y equals to mx plus c, right? So the x is the normal force. Now, this is also correct. As you can see on our x-axis, it's the normal force. So, obviously, the coefficient of the static frictional force is actually the gradient of the graph. So, by comparing these two equations, we can conclude that the gradient of the graph is the coefficient of the static frictional force. So, now, once we already know this information, of course, we can implement it. Of course, we can find the coefficient of the static frictional force for rubber surface against concrete or against wooden. So we could just find it by calculating the gradient of the graph. So we all know the formula for it: y2 minus y1 over x2 minus x1. Now I have selected 2 points that is actually on the best fit line. Okay, so the coefficient of static frictional force for the rubber surface against the wooden or the concrete surface is 1.2. So so for every experiment, we have to find the percentage error, and we can easily find the percentage error by subtracting the experimental value with the actual value of the coefficient static frictional force, and then divide it with the actual value of the static frictional force times with 100%. So I've used this formula, and I've also went on the internet to find the true or the actual value of the coefficient of the static frictional force, or the mu. So it turns out that we actually had 20% of error while conducting this experiment, and I feel like we could definitely improve that. We could definitely find our flaw and try to improve it in our next set of experiment. Now, we'll move on to the second graph, which is graph of frictional force against normal force for the non-rubber surface. Now, we'll just repeat the same step as we did for the previous graph, which is drawing the best fit line by finding the centroid, and then finding the coefficient of static friction by finding the gradient of the graph, and also the percentage error. So the centroid for the second graph is 3.75, 0.86, so that is the coordinate. And then the coefficient of static friction is 0.34. Now the percentage error is 45%, and I have to admit that it's a little high, and I definitely feel like we could improve ourselves in the next experiment. Maybe we could repeat the same experiment, but instead of the trial being only 3, maybe we can do the trial with 4 or 5, so that we could get the average as accurate as possible. So that is all from me. Thank you very much.
Okay. Discussion. Friction is an opposing force that resists the motion or attempted motion of one surface across another surface. Friction depends on the material of both the object's surface and its weight. The heavier the block is, the larger the friction. However, friction is independent of the area of the surface in contact. This can be proved by observing the graph in set 1, where the value of friction varies when different materials or weight are experimented with, but the values does not change when different areas are used. The friction force is presumed to be proportional to the coefficient of friction. These coefficients of friction are called for a given pair of surface, a coefficient of static friction and a coefficient of kinetic friction. The amount of force required to move an object starting from rest is greater than the force required to keep it moving at a constant velocity once it is started. Therefore, static friction is greater than kinetic friction. In set 3 experiment, the friction caused when using rolling rod is so small that it can be considered significant. This is because the table is horizontal and there is no component of force tangent to to the surface. Hence, even if the coefficient of static friction were 0, there would be no sliding. Therefore, the static friction force is 0. The relative velocity between the surface of the ball and the horizontal surface near the point of contact is wholly normal to the plane. Therefore, the kinetic friction force is 0. Hence, we could say static friction to kinetic friction to rolling friction for the same combination of surface. Due to inconsistent forces in this experiment, when pulling the block, it is best when one person pulls the block in 3 trials. Also, the experiment cannot be accurately measured. Therefore, a larger and more sensitive dynamometer is needed in the future. This will make the data more accurate and less erroneous.
Now I want to present about conclusion for experiment frictional force. In this experiment, we will conclude that the static friction is acts on an object that is at rest. So we can find the maximum ratio of applied force to normal with no motion, which is coefficient of static friction. Then, from that, we can observe the different coefficient for both surfaces are tested. That's all. Thank you.